So good afternoon, AP Stats kids. It's Tuesday, April 7th. Good to see you guys again. I hope you were with Luke yesterday. And as of yesterday, we are now reviewing topics that could be on this year's 2020 modified exam. I hate to say will be because Luke and I have no idea what's on this year's exam. But as of yesterday, from now until Friday, May 1st, we are going to be covering topics that are in the revised curriculum, in the revised exam. And so hopefully these sessions are, laser focused on, again, what you guys could see on this year's exam. Again, I have no idea, no inside information what's on this year's exam. So Luke and I tried to pick topics that we felt were the major topics or themes of the course. So again, welcome back. It's Tuesday afternoon. There's our intro slide like you've seen before. Again, my name is Brendan Murphy. I teach at John Baptist Memorial High School in Bangor, Maine. I was just talking to an old friend this morning who emailed me. He's an AP Stats teacher in Florida. He's an awesome teacher. He and I go back about 20 years ago, and as soon as he heard me open my mouth, he knew it was the same person. So I have a Boston accent, born and raised. Lived in Maine for the last 20 or so years, and so it's probably a combo Boston-Maine accent. So if I talk funny, I apologize. I hope you guys can understand what I say. Luke is our other presenter. Luke and I are good friends. We've worked together for years, and he does an awesome job. I actually like to sit in and listen to his sessions as well. So welcome back. Here's your homework that he gave last night, and I'm just going to zip ahead to a slide and then come back to this problem, and I'll explain why. So anytime when I start teaching inference to my own students at John Baptist, what students I think struggle with perhaps is what we call, picking the right test. We teach them all these different confidence interval tests and hypothesis tests. And my students always say, I have a hard time, Mr. Murphy, figuring out what test I should use and then finding it on the calculator. And so I came up with these 4 questions. And every time we do an inference problem, literally for 2 or 3 months in a row, after we read the problem, I'll call on a student and say, let's answer these 4 questions and see if these 4 questions help us, 1, identify the correct test, and 2, perhaps finding the right test on the calculator, all of which we'll practice today. So my first question is, does this problem feel like a confidence interval or a hypothesis test? And sometimes the wording is very easy in the problem, and sometimes it isn't quite so easy to figure out exactly what they want. Other teachers may frame it in a different way for confidence interval, find some values or something like that, or for a hypothesis test. Is there evidence that this is stronger than that, or yes, no? So lots of different ways to do that. But I think my first gut reaction is this problem going to be a confidence interval or a hypothesis test? My second question is, do we have 1 sample or 2 samples? So that's going to be important. Have we, just 1 set of data or 2 different sets of data that we need to analyze or compare? Third question, are we dealing with proportions or means? And so I will always say, we got to get on the right highway, guys. Do we want to be on the proportions highway, or do we want to be on the means highway? We won't switch highways during the problem. And then finally, do we need to read a Z table or a T table? Or again, you could clearly go to your calculator and find the right values or whatever. But some students like to read tables. I think last week I said that I was a little old school, perhaps, and I still teach reading a table. But if you're good to the calculator, good using your calculator, that's okay too. So again, if we can answer these 4 questions correctly, it helps them to quote unquote name the test, and I'll model that later today. Perhaps get into the problem, and again, hopefully we solve it correctly. So I'm just going to go back to Luke's homework problem. I'll give you 20 seconds or so to read the problem, and then we'll dive into it. So I think this is what he was doing yesterday, confidence intervals with 1 sample or 2 samples with proportions. So researchers are studying the distribution of subscribers to a certain streaming service in different populations. Just setting the table, I guess. From a random sample of 200 people in city C. 34 were found to subscribe to the streaming service. From a random sample of 200 people in city K, 54 were found to subscribe to the streaming service. So there's some numbers. Sort of feels like two samples to me, but let's keep reading. Assuming all the conditions for inference are met. So that's important. This is a multiple choice. And again, we can't run any of these tests. They have no validity unless the conditions have been met. So in a multiple choice, many times you'll see that. Which of the following is a 90% confidence interval for the difference in population proportions? City C minus city K, who subscribe to the streaming service. Just a little side note, we've been reading the AP Stats exam in Kansas City for the last, 8, 10, 12 years. And when I read that, I kept reading Kansas City, although there's no Kansas City clearly at all. So here goes with my 4 questions. I would say to my students, does this feel like a confidence interval or hypothesis test? And clearly it's a confidence interval. So that feels easy for my students. Do we have 1 or 2 samples? And students might read it again, but it feels like we have 2 different samples, Mr. Murphy, one from city C and one from city K. My next question is, are we dealing with proportions or means? Which we get on the right highway. So what highway do we get on? And we want to get on the proportions highway, it feels like, right? We have 34 out of 200 or 54 out of 200. And then I might say to students, if we need to, are we going to go read a Z table or a T table? And so hopefully they would say Z table. And by naming by answering those 4 questions, hopefully they've quote unquote named the test. And so here's the same problem. And so it feels like I was doing a confidence interval, and we agreed that we had 2 samples. We were dealing with proportions, and I'm going to read a Z table. And so that's the name of the test. Now there's lots of other ways to correctly name that test. That's my way of doing it. I do try and stay away from the calculator speak of the problem. I just don't like it. It feels like that's not the name of the test. That's what Texas Instruments calling it, but that's not what I want to call it. So I don't use calculator speak kind of at this point here. And so I did a little math down here. P hat for city C was 34 over 200 or 0.17. P hat for city K was 54 over 200 or 0.27. And so unfortunately, I cannot eliminate any problems because all of those have the correct difference of the 2 cities. And again, the problem said city C minus city K. They did tell me 90% confidence. So if I go to my calculator, I can probably get that critical Z value, right, that I need. So let's clear this off. Bars, second bars, let's try that. Inverse norm. Now be careful here. I think we talked about this last week, and I'm sure Luke did as well. For 90% confidence interval, my area is actually 0.95. It's the 90% in the middle. And adding 5 for the lower tail. And so my critical Z value is 1.645. You maybe have memorized that, but just be careful with that. It's really easy to type in inverse norm 0.90. It's really easy to do that. And so once I got that critical Z value, I think I was able to cross out a couple of my answers here, right? Because I'm looking for the 1.645 rounded. So it felt like I was pretty quickly able to get rid of those 2 problems. I did write down the formula for a confidence interval with 2 samples with proportions, p hat 1 minus p hat 2, plus or minus critical Z times the square root of p hat 1 times 1 minus p hat 1 over n1 plus p hat 2, 1 minus p hat 2 over n2. And that formula probably isn't given to you on the AP Stats exam. You probably won't need to ever write the formula, especially on a free response if we've named the test. But as a math teacher, it's not that hard for me to memorize it after teaching the course for a good 20 years or so. But we don't necessarily expect you to memorize that. But you can see up here that the format of all of those is basically the same. So I just started to plug in some numbers down here. And so there was my p hat 1 minus p hat 2, and there's my 1.65, again rounded. And so I did p hat 1.17 times 1 minus p hat 1, 0.83 over 200, and did the same for my second sample. And when I looked above, I actually didn't see that answer. And so at first I thought, boy, I think I'm doing it right. Like I don't know why, what's wrong here. And so it clearly wasn't A based upon that. And so I was really down between C and E. And I had to think for a second. And then I said, well, going back to my formula here, down the bottom here, I guess we have the same denominators, right? And so I can just kind of get rid of that plus sign here, keep that plus sign. And I just have a common denominator of 200. And so that left me with answer E, which we hope is the correct answer. So that was a nice little problem that Luke gave you guys for homework. Again, I was using process of elimination to my benefit there. I was trying to get rid of answers that didn't make sense, and literally by finding the critical Z value, I was able to, I think, get rid of two different answers. So nice little problem from Luke last night. Hopefully you guys were able to perhaps take a look at that, or maybe makes some more sense right now. Again, I think I showed you guys these two websites last week. As the College Board is releasing more and more information about this year's exam, when, what time, all of those things, these two websites, I think, will be super helpful to you and your teachers. So please feel free to share with your teachers. If they're not going to these websites, it will help them figure out exactly what's on this year's modified exam, and therefore help you guys do well on the exam this year. And so I'm going to talk about today hypothesis tests for both one sample and two samples with proportions. So the test statistic for population proportion is Z equals p hat minus p sub naught, all over the square root of p sub naught times 1 minus p sub naught over n. So that's the formula that we're going to use for one samples. And I took this right off the what we call the CED course and exam description, probably more for teachers than you guys, but little clarifying statement here, which I thought I just wanted to read to you guys. The formulas for many of these test statistics do not appear explicitly on the AP Stats formula sheet during your AP exam. However, don't let that bother you. These formulas do not need to be memorized. You can probably do all of these problems without even having to write down the generic formula, as long as you name the test. And they can be structured. We can put those together pretty easily by having a rough idea of what we're trying to do. And of course, the relevant standard error formulas are provided for you. So that sometimes it's the hardest for my kids. And there's a subtle nuance, probably Luke talked about it yesterday, when we actually do two sample hypothesis tests. So here's the formula for two sample hypothesis tests with proportions. Again, we have p hat 1 minus p hat 2 minus 0. I'll explain where that 0 comes from when we walk through a problem. What's a little different here is the denominator, the standard error. I call it p hat combined. And I'll walk through the math of where this comes from and why is this different here with two samples. That's not probably what the formula you used yesterday with Luke if he did a two sample confidence interval with proportion. So there is a subtle but important difference here, and I'll explain why we have a p hat combined. So some books call it pooling. I think I like combining better, and that's just maybe my preferences. So p hat combined is we're taking a look at both of our samples. Okay, so I think I went through this again. Each time we do a problem, I'm going to try and do at least a couple, 2 or 3 later in the presentation. I like to ask my students these 4 questions, and they get pretty used to them. And if they can answer those 4 questions correctly, hopefully they've, one, named the test, and two, are kind of heading down the right path to solving it. Okay, so here's the $64,000 question. Like, why do we need to calculate this p hat combined, and what does it really mean? Like where does it come from, and what's its relevance? So I have sort of a hypothetical here. I'm going to come up with some numbers that are pretty easy. And so if I've decided that I need to do a two-sample hypothesis test with proportions, my null hypothesis is probably P1 equal P2. And of course, I would want to identify those parameters either in words or in symbols. So we think that the two population proportions are the same. That's the claim that I'm making, and that's my null hypothesis. And of course, my alternative could be any one of my three options. They're not equal, greater than, or less than. And that really isn't identifying what the p hat combined is, but I'll try and tackle that and show you why we come up with it. So let's say a p hat 1 is 20 over 50, or 0.40. So my first sample from some population is 0.40. And if my second sample, and I tried to pick relatively easy numbers here, 30 over 60, or 0.50. So I really know nothing about my population parameters at this point. I've taken two smaller samples. The first sample was 20 over 50, or 40%. The second sample was 30 over 60, or 50%. But again, what's the first thing I wrote down on my paper was, well, those two population proportions are the same. The problem is I don't know what this is. I don't know what that is. And of course, whatever they are, I'm saying they're equal. So what we do is we take our two samples, and we want to combine them. So my total successes would be the 20 over 30. My two sample size would be 50 over 60. So I get 50 over 110, or 0.454. And so I think that's sort of my best guess as to what that number is, and or what that number is. They're both the same, based upon my two samples. And again, I don't actually know what that is or what that is, but I've made the claim that they're the same. The only information I have is my two small samples here. So I'm going to kind of combine those to come up with, I think, is perhaps my best guess estimate as to what either one of those two numbers are. Now, the first question my students ask is, Mr. Murphy, why isn't it just 0.45? Why isn't it right in the middle of those? I understand that you have two samples and you're trying to come up with what you think is the best number here, Mr. Murphy, but why isn't it right in the middle? And the reason is those two sample sizes are not the same. And many times they won't be the same. And so I kind of call it like a weighted average, perhaps. I don't know if that's 100% correct, but sort of a weighted average based upon the two different sample sizes. How's that? So I think one of the problems that I do today has these two the same, and another one has those different. And so that's what this p hat combined means, or p hat c means. We've taken two samples. We actually know nothing about the two population parameters, although we claiming my null is that they're the same. And that's all I did here was combine those two, the 20 plus 30 over the 50 plus 60. So hopefully that helps you a little bit as to where that formula comes from and why we need to use that. So let's go look at some problems here. I found a couple of free responses that we can take a look at. So the first one's an oldie, but it's a goodie. So this is from 1998, which was our second year in business. It was the second year of our AP Stats exam. And I think I'm only going to do part A here. There's that Boston accent, right? Part A. Part B we'll talk about real quick, but I wanted to do a one sample test. So let me give you a minute or so to read that, and then I'll ask my 4 questions again, right? That gets us into the problem. Hopefully helps us name the test and head down the right path of trying to solve it correctly. So go ahead and read the problem if you want and see if you can figure out what type of test we're going to need to do. And one of our review sessions, I think towards the end, maybe closer to the May 1st date, is going to be name that test. And so, again, Luke and I are going to come back after we've gone through all of the different tests. Yesterday and today were proportions. I think tomorrow and Thursday are means. And then at some point, we're going to come back and say, well, you know, what are the clues in the problem to help us name the right test? So a large university provides housing for 10% of its graduate students to live on campus. So that's just setting the stage, I guess. The university's housing office thinks that the percentage of graduate students looking for housing on campus may be more than 10%. So I think they've kind of given me the null and alternative, but let's just keep reading and see if we can figure that out. The housing office decides to survey a random sample of graduate students. Well, that's always a good thing, that random. I sort of always like that. And 62 out of the 481 respondents say that they are looking for housing on campus. Okay, so I think I know where we're going, but again, I think I would ask my students those 4 questions. You know, does this feel like a confidence interval or hypothesis test? Again, some other teachers say things like, are we looking for a number, an interval? Are we looking for a yes, no? So this feels like a hypothesis test to me. There's nothing in there leading me to think that it's a confidence interval. Do we have 1 or 2 samples? Oh, we just have 1, so that's good. I'm going to get on the right highway, right? I'm going to get on the right highway. So are we dealing with proportions or means or averages? And it feels like 62 over 481 is a proportion and not a mean or average. And at some point, if need be, I would probably go read a z-table or do a z-test on my calculator. And so that's the first thing I want to do, is literally name my test. So again, lots of different ways to name this test. I call this a one sample hypothesis test with proportions. I'm sure you have some wonderful teachers who have taught you other ways to name it, and that's perfectly fine, but that seems to work with me and my students. And it's going to be pretty easy for me to hopefully go find that correct test on the calculator. When I start to punch some numbers in and try and get some values, I think naming that test will be very helpful to me. Okay, so part A, on the basis of the survey data, would you recommend that the housing office consider increasing the amount of housing on campus available to graduate students? So I need to make a decision. Should we build more housing? Give appropriate evidence to support your recommendation. So of course, at this point, you guys fully understand that yes and no answers are just not what we're looking for at this level. And so I'm probably going to need to run a full-blown hypothesis test. But I know what I'm doing. It's a one sample hypothesis test with proportions. So to me, the first step is, come up with my null and alternative. So my null hypothesis is P equals 0.10. So that's the population proportion of students. And there were a couple clues in the problem here leading me to feel like my alternative needed to be greater than. So my alternative is that the proportion is greater than 10%. Right now, we don't really think that's enough right now, So I'm sure Luke talked about it. We need to identify that parameter. What does P mean? Like, what does P mean in this problem? So over here, I said P is the population or true proportion of graduate students at this university who would prefer campus housing. So I've sort of identified that, and we want to make clear that that's a population parameter. So that's always my first step, is come up with my null and alternative hypothesis. Came up with my P hat, or my sample proportion. There were 62 out of 481 students who did say that they would be interested in perhaps living on campus. And so I did a little math, and that's 0.129. Well, that number is greater than the 0.10, but at this point, I'm in no position to really make a decision without running a test. There's so many other factors that impact it. But it does feel like that is greater than the 0.10, and so maybe we do need some more housing, but I'm in no position right now to make that decision. So my step 2 is always listing my assumptions and checking any conditions. So my first one, the data was randomly selected as stated in the stem of the problem. That's always a good thing. And that probably pretty much needs to be there. For some reason, if that wasn't part of the stem of the problem, I think on the AP exam, I would write something like, I'm going to make the assumption that the data is randomly selected. So if you're ever bothered by a condition that you don't think has been met, as opposed to just not doing the problem, down here you can always say, I'm going to proceed with caution, or I'm going to proceed with the problem based upon blank. And that's what we want. We want students to think about the problem and what conditions do we need to check for us to run the test. So my sample size times piece of knot, I call these, the NP checks, okay? And we actually need to see your numbers in math. So you can't kind of just stop here and put a check mark and a check mark. We want to see that you've plugged in the correct numbers and done some math. So I said 481 times 0.10, or 0.1. That was 48.1. Well, that was greater than 10, so that's good. N times 1 minus p sub naught is greater than 10, so 480 times 0.9 is, I think I rounded there, that to 433. That was greater than 10. Well, clearly, both of those are greater than 10, so I'm happy with my sample size based upon my null hypothesis. Now, be careful here. When we're doing hypothesis test, that value there and that number there are based upon your null hypothesis, which is sort of the first thing I wrote. Yesterday, maybe Luke used the sample proportions. And hypothesis test, kind of the first thing I wrote after the name of the test was the population proportion was 10%. So I want to use those numbers. So the sample size looks pretty good. I want my population to be greater than 10 times my sample size. Again, we want to see you plug in some numbers. We want you to do some math. So I said the population, is it greater than 10 times 481? Is the population greater than 4,810? Again, I have no way of confirming this. This feels like it's an assumption, whereas it felt like that was a condition that I could mathematically check. So I said it's reasonable to assume that at a large university, or that this large university has more than 4,810 graduate students. I don't know that for a fact. There's no way I can prove it, but we still want you to address it and make an assumption. And it's reasonable. It did say a large university. The University of Michigan may have 100,000 students. I don't know how many graduate students, but they probably have way more than 4,810. So sort of feels like step 2. I'm good. I've checked my conditions. So now I want to go to what I call step 3 is my math or mechanics. Again, different teachers may call it different things, but it's pretty much all the same thing. Now, I do not need this formula on the AP exam if I've named the test, which was the first thing I did. And again, the name of that test came out off of those 4 questions that I asked. So when I'm teaching it, I do ask my kids to write the formula down. I think it's good practice. But as we get closer and closer to the AP exam, I say, guys, if you've named the test, you don't really need the generic formula. Excuse me, you can see I've plugged in my numbers over here. But I really want to go to a calculator right now, and I want to get those 2 values from my calculator. So I'm just going to go back to my calculator. We'll try and find the right test. Again, if I've answered those 4 questions correctly, then I think finding the test hopefully isn't that difficult. So I think I called it a 1-sample hypothesis test with proportions, a 1-sample hypothesis test with proportions. So I think it's test 5 here. Now that's not exactly what the calculator is saying, but I think I could find it pretty quickly, and my kids seem to be able to find it relatively quickly by answering those 4 questions. So that's good. Again, that name there feels, I call it calculator speak. Like if you don't use the TI series, you might not know what that means, but probably all statisticians would understand what a 1-sample hypothesis test with proportions represents or means. So it looks like I probably typed in my numbers here, P sub naught. We said, well, that was 0.1. That was my second thing I wrote after the name of the test. I had 62 out of the 481 said they wanted graduate housing. So that was my P hat. My alternative was greater than. Again, I got that wording straight from the problem. It said, does the university need to build more housing? Or was it greater than the 0.10? So I'm going to go ahead and just get my numbers right from the calculator. So my z-value is 2.11. My p-value is 0.017. You don't need all those decimals. If you want to write them, you can. P-hat, I think I had 0.129. That was pretty close. So so I'm going to write those two numbers down on my paper. And again, if you've named the test, that's it. That's all you need for the math of the mechanics. And so those two numbers are critical, and they need to be on your paper somewhere. So probably the most important thing now is conclusion and context. So my first sentence is going to be somewhat generic-y here, i.e. I could use it probably on every problem. Since our p-value of 0.0173 is less than our assumed significance level, alpha is 0.05, we reject the null hypothesis in favor of the alternative hypothesis. So that rolls off my tongue. I've taught the course for the better part of 20 years and have said that thousands and thousands of times. But there's no context there. So my first sentence is somewhat generic. I want to compare my p-value to my assumed alpha significance level, and I want to make a decision. So I've rejected the null in favor of the alternative. I don't like the word except, so I'll never use that in any of my conclusions. But my next sentence really has to tie it into this problem. So the data provides convincing evidence that the population proportion of graduate students at this university looking for housing on campus is greater than 10%. I haven't said I've definitely proved or anything. That's not what a hypothesis test does. But the evidence that we've collected is leading me to believe that perhaps the university does need to build more housing and or that it's more than 10%. So that's a nice little problem, one sample. And I'm going to try and do a two sample here in our remaining 15 minutes. And this was a lot of work. This took me 2 or 3 pages here, so I hope I have enough time. I think I'll have enough time to go through this. So this was from the 2012 exam. I was actually part of this, what we call rubric team. So I was part of the team that actually came up with the scoring rubrics and trained all the readers. And so I spent probably 5 or 6 days of my life on this problem and know it well. And so it's one of my favorites, and perhaps I'm a little biased because I worked on the problem. So this was from the 2012 exam, problem number 4. I'll give you a minute or so to read it, and then we'll kind of dive right into the problem. And I think I'll have enough time to finish it. Okay, so a survey organization conducted telephone interviews in December 2008 in which 1,009 randomly selected adults in the United States responded to the following question. At the present time, do you think television commercials are an effective way to promote a new product? Okay, so at this point, it almost feels like experimental design to me, but I obviously need to keep reading. Of the 1,009 adults surveyed, 676 responded yes. Okay, so that feels like a proportion to me. In December of 2007, 622 of 1,020 randomly selected adults in the United States responded yes. So now I have 2 different years, 2007, 2008. Feels like 2 different proportions. And so I'm sort of changing my mind here. I think I know where we want to go, but let's keep reading and see if we can figure out exactly what this problem's asking. Do the data provide convincing evidence that the proportion of adults in the United States who would respond yes to the question changed from December 2007 to 2008? So again, I think I know where we're going, but I'm going to ask my students these 4 questions. Does this feel like a hypothesis test or a confidence interval? Feeling more hypothesis test, convincing evidence, or convincing statistical evidence. Probably a hypothesis test. Do I have one sample or two samples? Well, I clearly have two samples, right? I have the first sample here from 2008, and then the second sample there from 2007. Are we dealing with proportions or means? So again, proportions. These aren't averages. These are one number over another number, proportions. And at some point, am I going to read a z-table or a t-table or go do a z-test or a t-test on my calculator? And I think the answer is z. So based upon those first four questions, I'm going to call this a two-sample hypothesis test with proportions. Again, your teachers have probably taught you lots of other good ways to phrase this. That seems to work with me and my students. And if I can answer those four questions correctly, I think I can name the test. And that's important. It's super important in this problem. If I've named the test, then I don't need to write the generic formula. So again, first thing I want to do is my null and alternative. So I said P of 2007 equals P of 2008. So those 2 years, the population proportions were the same. My alternative was P of 2007 is not equal to P of 2008. And I think I got that right up here where it said changed. It didn't say greater than, it didn't say less than or anything. It just said, or is there a difference? Did it change? Again, I spent a good part of my summer that year working on this problem. If students had put in those numbers here, we felt that was enough to define the population parameter. But let's get real. Let's write really strong answers here. And so over here, I'm going to define that parameter. So P of 2007 represents the population proportion of adults in the United States who would have answered yes to that survey question in 2007. P of 2008 represents the population proportion of adults in the United States who would have answered yes to that survey question in 2008. So again, only because I was on this rubric team, that was considered enough that year. I would get into the habit of writing over here, really identifying that parameter in a much better way. So, so far we're heading down the right path, I think. So I came up with the first sample P hat of 2007 was 622 over 1,020 or 0.6098. P hat of 2008 was 676 over 1,009, 0.6699. Again, I really don't know what that number is or that number. I have my two samples. Well, it's probably somewhere in between here, but I don't know exactly where. And so this is probably going to be that P hat combined that I mentioned a little bit earlier. Okay, so I need to check some conditions. Both samples were randomly selected as stated in the stem of the problem. Super important, right? We have two different samples and they both needed to be randomly selected. So students, if they said here, random sample check, they didn't get full credit here. We wanted them to say both samples or something to that effect. If they said samples, that felt more than one. But if students just said, random sample check or something like that, that wasn't enough. We really want you to think about these conditions and write or communicate about them well. So I want to make sure my population size is big enough. So is the population in 2007 greater than 10 times my sample size? Is the population in 2007 greater than 10 times 1,020 or 10,200? It feels like yes in the United States, but we'll come back and address that. Is the population in 2008 greater than 10 times my sample size? 10 times 1,009 or 10,090? Again, we need to see this math. We need these numbers on your paper somewhere. And so down here, I've said the population of the United States in both years is probably much greater than these two numbers. And so we're safe there. We're safe there. And so my third one, I call them my NP checks. This was a lot of work here, and I'll try and explain why I did it twice. So in 2007, there were 622 yeses, 398 no's. Add those two up, you get this number. 2008, 676 yeses, 333 no's. Those add up to 1,009. So all of these counts are greater than 10. So we're pretty convinced that my sample size is big enough based upon my proportions. I remember having discussions about the best way to do that, and this was years ago. It feels like we're now leaning towards a different way of doing it, and this was in the revised curriculum that the College Board came out with this year. So I did figure out p-hat combined. I added my 2 successes over my 2 sample sizes, and I got 0.6397. Well, that does feel like it's kind of between these 2 numbers here. And so that's probably a better estimate as to my population proportion for either year. Again, I'm making the assumption that they're both the same. So that feels like it's a better number than either one of those 2 samples. So I multiplied my sample sizes times that number. I got 652 and 367. I did that for both years, 2007, 2008. And again, you'll see that all 4 of those numbers, all 4 of those counts are much greater than 10. So we're good. I think moving forward, we want students to use this p-hat combined here as opposed to the 2 different samples up here. But I'll leave that up to you and your teachers. That's how I'm stressing with my kids now. And I remember having great discussion at that with college professors, and we went round and round on that. But today I'm pretty convinced that I want to be using this p-hat combined here. So now I need to do some math and mechanics. You can see I've written out the formula here for 2-sample hypothesis test. Z equals p-hat 2008 minus p-hat 2007. You could have subtracted the other way, but I think this number was bigger than that number, and I don't like negative numbers, so it doesn't really matter how you do that. Here's my standard error, and this is a little tricky here. P-hat combined times 1 minus p-hat combined times 1 over n 2008, 1 over n 2007, and the whole thing square rooted. I would suggest not trying to do that on the AP exam if you don't have to. That can be a little tricky, and that's hard to memorize. So as a math teacher, I'm good with it. But again, if we've written the generic, the name of the formula or the name of the test, which I did, that's the first thing I did, then I don't need that. I don't need that formula. So let's go to our calculator, see if we can get some numbers here. So let's go to our tests. So I think I called this a 2-sample hypothesis test with proportions. So it feels like 6 is going to be my the correct test. Again, it's not exactly how I named it, but I think I can find it pretty quickly. Again, that to me is calculator speak, and I want to use good statistical communication. So my first sample, I think I had 622 out of 1,020. When we were grading this, we did see kids messing up the numbers, and as long as we could follow along with the math, I think we were pretty lenient that year. There were a lot of numbers. 2008, I think, was 1,009. My alternative was they were not equal. So I'm going to ask the calculator to do all the math that I don't want to do. My Z statistic is negative 2.82. Again, if you had subtracted the other way, it would have been positive. My p-value is 0.00476. That's a pretty small, that's pretty low p-value. P-hat 1, P-hat 2. And this here this third p-hat is my p-hat combined. So that's, I think all those numbers feel like the same numbers I got. So I wrote down my Z-score here and my p-value, so I put that on my paper. So I wrote those down here in my paper. Again, if you had either the positive or the negative, it just meant you subtracted differently than I did. My p-value was 0.0048. Well, that's pretty small. I think I know what my conclusion wants to be. And so I said something to the effect of, again, my first sentence will feel generic-y. Feels like I can use that year after year after year. Since our p-value of 0.0048 is less than our assumed significance level alpha is 0.05, we reject the null hypothesis in favor of the alternative. So again, that's sort of half of a good conclusion. I've stated my p-value, I've compared it or linked it to my significance level, and I made a decision, okay? But there's no context, and I really have to make a decision as it relates to this problem in that original quote. The data provides convincing evidence that the proportion of all adults in the US who would have said yes to the question of effective TV commercials changed from December 2007 to December of 2008. Again, lots of ways to say that correctly, but I need to get in there my p-value, I need to link that to my significance level, I need to make some decision, I either reject or fail to reject, and then I want some conclusion and context here. So that's a lot of work. That is a lot of work for one problem, and I think the two-sample hypothesis test with proportions is some way harder than the two-sample hypothesis test with means. I think I'm doing that on Thursday afternoon. I think Luke's doing confidence intervals tomorrow. So that feels like those are sort of the longest problems, at least for me. So I'm just going to go back to my PowerPoint here. We did that problem. That's the one we just finished for the sake of time. From 2015, it felt like this was, if you want another practice problem, you know, that I think is another two-sample hypothesis test with proportions. So if you want to practice that tonight, feel free, 2015, FRQ number 4. So at this point, you're hopefully feeling more comfortable with both confidence intervals and hypothesis tests with proportions, both 1 and 2 samples. I know Luke did confidence intervals yesterday. I did hypothesis tests today. We weren't sure exactly if your teachers had taught you these, again, before we all of our schools closed down. So we wanted to get this kind of a sort of a quick, fresh review. And if it's new to you, great. Hopefully we've taught you some few things. If your teachers got here, hopefully it was a good review. Similar to all the other inference tests or procedures, you should be able to write a clear, concise solution in context. I can't overemphasize how important that context is. Relate your answer to the problem at hand, not some generic statement. Although my first sentence and my conclusion is somewhat generic, I always follow up with a contextual answer. Here's your homework for tonight. It's a multiple choice. It kind of looks like a confidence interval to me, and probably it's with means, but I'll let you guys read that yourself, and Luke will start out tomorrow with that. So let's wind down and we'll call it an afternoon. I appreciate your sitting through again. The College Board knows that not all students have access to the internet or device. That's just a fact of life. And the College Board will do anything humanly possible to help you out. So the College Board's working on solutions to help students get what they need to show their best work. So the assumption is that you'll be taking this test at home. You'll be taking it on a computer, tablet, or phone, and you're gonna have to submit your answers that way. So if you need mobile tools or connectivity or know someone who does, feel free to reach out directly to the College Board at that website below. Feel free to notify your teachers. You know, please, please, please let someone know that you want to take the test, but for some reason there's an issue with technology, and the College Board will bend over backwards to try and help you out. So again, thanks for watching. Tomorrow, Luke's doing confidence intervals with means. I think the next day I'm doing hypothesis tests with means. We hope you're all safe. We really appreciate your sitting in, and we hope you're helping. So take care of yourself, please. Stay healthy. Take care of your families. These are hard times for all of us, and we really appreciate your sitting in. So I hope I helped today. Enjoy the rest of the afternoon. It's sunny up here in Maine, but cold. And I just watched the news at lunch today, and we're going to get 6 to 12 inches of snow on Thursday night. So we're still in winter up here. So anyway, be safe. Hope you enjoyed today. We'll see you later this week. Thanks.